The UK farming industry is facing serious challenges. Uncertain payment structures, a shrinking workforce, increased food imports, animal welfare and climate change, all in the face of huge demands to provide food and improve the environment. In 2024, these challenges led to widespread protest across Europe, and the UK government announced a £220 million funding package for farming technology and innovation as a solution to some of these issues. Digital technologies in livestock farming are an emerging innovation that create, store, and manage large quantities of data. They may improve efficiency and profitability for farmers, but they also raise new questions about job displacement, privacy, corporate control over farming practices, and changes to the relationships between humans and animals. We also know that although the British public want cheap meat, they're concerned about the impacts of intensive farming on animals and the environment. So, what kinds of digital technologies do we want? And what sort of problems should they solve?
So the sheep come into the building for scanning. They're each weighed individually and they're injected with a mild sedative which is based on their live weight. Once the sedative has taken effect, which takes around 20 minutes, they're rolled into a cradle, positioned for scanning in the cradle, and then brought up on the lift into the scanner trailer, where they're put on the table and positioned, and then everybody leaves the room. The main advantage of CT scanning is the increased accuracy of the data that you get from the CT scans. So once the sheep have been scanned here, we produce all this information, we send it off to the farmers, and they're using it to be able to select rams which they can use to breed better lambs in the future. We give them measurements of the muscle shape, so the area and the depth and width of the eye muscle, so that's the muscle, the large muscle you see in a lamb chop. We give them details on the shape of the hind leg, which is called a Gigot score. So it gives you an idea of whether the hind leg's a rounded muscle or a long drawn out muscle. So depending on what they're trying to produce would depend on what they would want to select for.
Methane is a potent greenhouse gas, so reducing these emissions could slow global warming. The agricultural sector produces 40% of the world's methane emissions, with the majority coming from cow and sheep production. Cows and sheep produce methane from their rumens or stomachs. Existing CT scan data is now being re-examined to look at rumen size with the aim to breed sheep with smaller rumens that produce less methane. But methane reduction could also be achieved by bringing sheep to slaughter more quickly or simply by eating less meat, and these solutions might have far fewer animal welfare implications.
In some of our more recent research projects, that's really been the focus. Can we reduce the environmental impact of our sheep flocks? So if we can measure rumen volume from these same scans that we're taking for carcass improvements, potentially we could then breed for a smaller rumen that could produce less methane from an individual sheep. But before we get to that stage, we need to be able to see how those traits all relate to each other. So we've been looking at how rumen volume relates to some of the other important traits, particularly in a kind of hill environment like this. We want animals that can eat very poor quality vegetation up on these hills and can survive through the winter. So is making the rumen smaller a good thing for those traits as well? So I think it is really important that farmers are collecting data and understanding that data and using that data in some way on farm. There's no point in collecting loads of data if it's never going to inform any decisions that you're making.
Making data useful in wilder environments like Scottish hill farms is a challenge. By using GPS-enabled collars, farmers can monitor the location of their sheep in real time, understand their feeding patterns, and select sheep with certain traits for breeding. The data is also valuable for researchers and the companies providing and storing the data, but it also raises concerns about who should own the data and how companies might reuse it.
So this is a DIGITlab collar, which is a GPS tracking device which shows the ewe's current location as well as the past 24-hour locations. So it sits around the sheep's neck like this. It shows activity levels as well as the GPS location. The data comes in every 20 to 30 minutes from each collar, and that shows the current location at each of those points. Our data is sent from the collars to the LoRaWAN network that we have here on the farm, and that then sends the data directly to the company, which is in Spain, which is then shown to us on the DIGITlab app, which we can access online or on an iPad. To then get raw data for our research, we have to contact the company and they send the raw data through to us on an Excel format. This sort of data is important to us because it can show the way that individual sheep are utilising the hill, which relates to feeding areas that we have and also to different grass types and the difference between the different breeds and genetic lines. To see how they use the hill, what sort of areas they forage in, and try and work out how much of the additional feeding that we're giving to them that they're utilising, and then compare that to production data, so weights and condition scores, for example, to see which are the poorer and which are the higher performing sheep.
Consumer demands for cheap meat support intensive pig farming, so digital technologies are also being trialled to improve animal welfare in these systems. Most pig farming in the UK is intensive, with around 60% of sows and almost all fattening pigs being kept indoors. Confined spaces lead to outbreaks of disease and painful tail biting, which farmers manage to avoid economic losses. For example, over 70% of pigs have their tails cut off to prevent tail biting, even though this is illegal under UK law.
FarmSense is a project where we're hoping to give farmers a tool for automatically monitoring the health and welfare of their pigs 24/7. And to do that, we're going to test out and try out these two different technologies. One is a 3D camera technology, which can automatically weigh the pigs and also record their behaviour. And the other is this a way of detecting changes in the gases in the air, specifically the volatile organic compounds in the air, or VOCs. And changes in the levels of VOCs and the types of VOCs in the air, we think will change in response to the metabolic state of the pig in the way that they're responding to a disease challenge or perhaps to a stressful challenge of some kind. Behind the 3D cameras are algorithms which take that data that comes from the cameras and turns that into an understanding of, well, that's an object which is closer to the camera than the floor, right? So, and it's the shape of a pig. So it's able to pick up pigs in the group. When it finds a pig, it will generate an estimate of its weight, but then it also will tell us how it's moving around under the camera. It's known as machine vision technology, where you interpret, there's a computer which basically watches the image for us. We use behaviour as a way of assessing their welfare, but we're also interested in aggression when pigs fight each other, or tail biting, where they bite each other's tails. So those kinds of behavioural problems that can happen in capped environments. You know, you build up a picture of what's normal on that farm, what's healthy and what good pigs look like. And then as soon as there's some deviation from that, there'll be a warning system that flags that up to the farmer, who can then take action. And maybe it will just say, go and check this group, there's something wrong, or maybe it will say something much more specific, like it's disease X, or maybe the feeder's broken in that pen, maybe you should go and check. That's where I would like to think we can get to with this, and it will take us to a completely new level of welfare monitoring, which will be good for farmers and good for consumers to have that reassurance that the pigs are well cared for.
In recent years, a vision for farming has taken hold. Driven by sustainable or agroecological approaches that reflects the environmental challenges brought about by climate change and biodiversity loss. Most digital technologies are designed for large commercial farms, but digital technologies could have real value for agroecological farming. At a recent workshop, stakeholders explored this question, as well as findings from a new report from A Bigger Conversation, highlighting the unique needs and perspectives of agroecological farmers when it comes to digital technologies.
The term agroecology is increasingly used, and we've adopted it as an umbrella term for a range of alternative approaches to agriculture, ranging from nature-friendly farming, through pasture for life, through organic, through biodynamic, permaculture, and also radical agroecology, which is the agroecology around food sovereignty and the change of the food system through food sovereignty.
My hope for these dialogues is that we can approach an agricultural future that embraces complexity, because that really is at the heart of agroecology. It's a system that promotes social justice and sustainability and cooperation and all kinds of things that get left out very often of the innovation discussion. Government needs to take a broader view and a broader vision of the future of farming. The institutes that are funding innovation, they need to understand the difference between an intensive system, which we all know is kind of dragging us in the wrong direction, and the diversity of an agroecological system. I think particularly with digital technologies, what we've heard from the agroecological farmers that we are interviewing is that they really value them. They do value technology that connects them to other things, it connects them to information, connects them to people, connects them to the land. What they don't want is they don't want digital technology that replaces hard-earned knowledge or replaces human connection. And so there's a fine line to walk between providing digital technology that actually enhances the farm and the farmer's knowledge, and providing digital technology that replaces that entirely and automates it in some way. And that came through really strongly with agroecological farmers in particular. They want to be actively involved in the decisions that they make and the technology that they use.
If the claims and the aspirations of the agroecological movement to bring about a food system that is fit for purpose on this planet of finite and diminishing resources, that challenge can't be ducked. It's got to be dealt with.
Some digital technologies are currently being explored in agroecological contexts. Dung beetles are a keystone species. This means they are the glue that holds an ecosystem together. They recycle the nutrients in dung, improving soil and encouraging pasture growth. By removing dung, they also reduce habitats for fly larvae and stop the cycle of parasites moving between the pasture and the grazing animals. This could lead to a reduction in the use of chemical worming products, which are harmful to the environment and expensive. Dung beetles have declined enormously over the last decades due to intensive farming practices. Their presence can indicate whether a farm is environmentally healthy. But supporting digital technologies for agroecological farming may require a shift in how we prioritise the environment and animal welfare in farming.
I applied for an Innovate grant to develop camera traps using AI technologies to recognise species, and we decided dung beetles were probably as good a species to base this project on as any. Dung beetles have a value to farmers in the way they interact with the dung. On top of that, they also are a very useful indicative species as to whether or not you have an ecologically functioning landscape. That has a value, one, because of the integrated pest management that landscape can produce. So the dung beetles can help with pests in the dung, but on top of that, we hope that it could also inform policymakers as to the practices that we're carrying out, as to whether or not they're helping deliver public good. So if we've got they're a good indicator of biodiversity, and one assumes if we've got dung beetles that we'll have multiple other parts of the food web that are required to maintain those dung beetles. Later in the project, where we really needed a bit of help with the Python script and the imagery, then we're working with Payman Shadmani from the Living Systems Institute in Exeter University.
So we have the camera setups installed on the farm, and we capture videos from the natural habitats of dung beetles, and then we take those data in here and then we train an artificial intelligence network to identify different species of dung beetles in that specific farm. So this is a script I've written for just segmenting the objects from the images, and that tells us which different species are present in that farm and the population of the dung beetles, and that gives us some sort of a measure of how diverse are dung beetles in that specific farm.
The digital side of things is incredibly valuable because we've only got relatively short memories, and as a consequence, if you can record it digitally and build up a database of the experiences and changes that you've got, that is an enormously important outcome.
Digital technologies are developing rapidly in UK agriculture. While they have the potential to address some of the challenges, they may also have negative impacts, particularly for the animals at the centre of livestock farming. Ultimately, digital technologies should support good farming, but we may all have different ideas about what good farming is.
Well, good farming is basically sustainable farming, because if it's good, it has to be both sustainable for the planet and also financially sustainable for the farmer.
To me, good farming is high quality food production in an animal welfare friendly way.
Good farming to me is focused on both welfare and production.
Good farming to me is knowing the numbers behind the claims that you make, so having the data to back up any decisions that you make in terms of management or breeding strategies.
Good farming to me is farmers that can take the time to really watch their animals, get to know them, check they're okay, really care for them.
Good farming is farming that works within ecological boundaries. It's as simple as that.